All right, let's look at number 4 here. Number 4 here says a factory manufactured lamps. It's known that the probability that a lamp is found to be defective is 0.05. A random sample of 30 lamps is tested. So this, if you read the question, you know this is a binomial probability. Okay. You're testing 30 lamps. Defective is going to be your P, so P is 0.05. Find the probability that there is at least one defective lamp. So anytime you see at least, I said the best way to do this is to do 100% minus the probability of no defective. Right? So 100% subtract probability of no defective will give you at least one. But how do you have no defective? Well, that's only one scenario, which is all 30 lamps are perfectly fine. So that's going to be 0.95 to the power of 30. Now you can think of it as a binomial and think of it like 30 choose 0. None of them is being defective. All 30 of them are good, right? But it's going to be the same thing anyways. Some people can think of it this way. It's going to give you the same answer. Okay, put it in the calculator. This is about 0.214638. This is equal to round off to 3 sig fig, 0.785. So that's part A. Part B, the keyword here is given that, right? And as I said in class, anytime you see given that, bling, 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 that's your conditional probability. Right. Anytime you have conditional probability, the condition goes in the denominator. What's the condition? The condition is given that there's at least one defective. Well, probability of at least one goes into the denominator. Find the probability that there are at most two. So this is probability of at most two overlap or intersect, probability of at least one. Okay. So what's in the denominator? Well, the denominator is whatever you get in part A, which is about 0.785, right? That's the probability of at least one. That's part A. Now, part B, it's a probability of at most two, but it has to be overlapping probability of at least one, meaning you're not counting the probability of no defective in there. Okay, so this is like probability of at least one to at most two. So you can do it a number of ways. You can do the probability like for the binomial probability here, and you do 2. So you can do it separately, like 30 choose 1. So that would be 1 defective. 0.05 to the power 1, 0.95 to the power of 29. And then you add 30 choose 2. So now that's 2 being defective. Okay, so that's one way of dealing with this particular question. Another way of dealing with this question would be to take using a calculator, right? Using the functions on the calculator, the binom probability, binom CDF. So if you do binom CDF, then you have number of trials, which is 30. The probability, which is 0.05, it's at most 2. Okay. If you do that on the calculator, it's going to give you 0.812178. Now, but that includes 0, 1, and 2. So I need to take away, subtract the probability of no defective. And you remember we did that earlier. Probability of no defective is 0.214638. So the numerator can be the difference between the two, 0.812178 subtract 0.214638. So that's the sum of 1 and 2, right? So here I do 2 subtract 0, or you can add the 1 and the 2 separately. So doing that math and punch in the calculator, you should be getting 0.761 if you round off the 3/6. Okay.